Hello dear students, welcome to YourPedia. Today in this session, I am going to discuss the questions that were asked in Power Grid Corporation of India Limited interview previously for electrical engineering candidates. Let's see those questions one by one. The very first question is, yes, what are the advantages and disadvantages of HVDC? Yes, we know what are the advantages and disadvantages of HVDC. With HVDC, stability is, there is no problem of stability, we know that, right? See, this problem of stability will come only with the HVAC, not with HVDC. Power losses will be reduced with HVDC. See, like that there are many advantages and disadvantages. Those all are listed here. Let's go through those one by one. See, the very first advantage is lower transmission losses. Yes, transmission losses are less in HVDC. You know the reason why. Next, enhanced power transmission capacity. Yeah, the second one is very important. That is, see, for HVAC transmission, we have some limitation on length of transmission. So the length of transmission should not be more than 500 kilometers. For that, we even will derive that length as less than 400 or 500 kilometers by taking power system stability. But when it comes to HVDC, that concept of loading angle delta power system stability is not there. That's why to what length you want to transmit power HVAC, we can transmit. Improved stability and control. Yes. Integration of renewable energy sources. Yes. If you are going with HVAC, it's not possible to connect directly to the grid. If you are going with, I can say, windmill, there is windmill. In windmill, induction generator is used, but we can't connect directly that induction generator output to the grid. In between, we have to connect AC, DC, AC cascade. We have to convert that AC to DC, again DC to AC of required frequency. You know, for the parallel operation, voltage and voltage, frequency, all this should be same. All voltage of all incoming machines and phase sequence of all incoming machines and frequency of all incoming machines must be same for the purpose of parallel operation. So that those many conditions are not there in HVDC. Yes. Interconnection of asynchronous grids. Yes, so all our grids are synchronous grids. Our total our grid is synchronous grid, but with HVDC we can go with the asynchronous grid also, right? Yes. Come on, what are the disadvantages? Let's understand the disadvantages. So higher initial cost. Yes, the initial cost involved with HVDC is very high. Why? Because we have to go with the converting stations. Yes, I have to convert from DC to AC to DC, again DC to AC, and one more thing, there are losses also in the converting stations. Yes, power electronic converter losses also will be there. Extra equipment cost is required. Extra equipment cost is required. Therefore, initial cost is high in HVDC. Second one, converter station complexities. Yes, whenever a new equipment or extra equipment is there in the system, definitely that is going to cause some problem. Let's read it clearly. HVDC systems involve converter stations at both the ends. Yes, at both the ends we need. Generation side is AC, utilization side is also AC. In between we are converting into DC. So AC to DC at the sending end side and a DC to AC at the receiving end side. Yes, of the line. These stations require additional space, infrastructure and maintenance compared to AC substations, adding to the overall complexity and cost of the system. Yes, very much yes it is. Next, limited transmission distance for underground cables. Yes, see, overhead transmission to what distance you want, you can go with HVDC, but in HVDC it is limited because when it comes to underground or submarine cables, HVDC transmission distance are limited due to higher costs and technical limitations. Yes, here economics is playing a role in the distance of DC underground transmission. For overhead, yes, when compared to AC, DC to what distance you can transmit, to that distance you can transmit. Why? Because HVDC is not having the problem of stability, right? Harmonics and electromagnetic interference. Yes, see, power electronic converters when involved, definitely harmonics will be generated and there is a possibility of electromagnetic interference. Next question, second question that was asked is, what are the devices connected at the terminals of HVDC or converting substation? We all know rectifiers will be there, transformers will be there. Let's see those things in detail. Converter transformers. Yes, transformers are responsible for stepping up or stepping down the voltage levels between AC grid and the HVDC converter station. They provide isolation between AC and DC systems and may also include filtering components to reduce harmonics. See, transformer is performing these many tasks. It reduces the harmonics. Yes, it is acting as a coupler between AC to DC, right? Yeah, that is one advantage. Yes, there are many I can say devices. I told you. See, the main purpose of transformer is to convert, is to step up or step down, right? Next, converter models. HVDC systems uses power electronic devices such as thyristors, IGBTs, arranged. These modules are responsible for converting AC power to DC power during the rectification process, or vice versa during inversion. Yes, we have to use power electronic converters for converting from AC to DC or DC to AC. At both the ends, we must have these power electronic devices. Next, filters. See, pure AC or pure DC we won't get with help of this power electronic converters. Definitely we have to go with filters. That is the third equipment. Fourth one, reactive power compensation. Yes, we have to go with reactive power compensation, static power compensators, those devices. Read it. HVDC systems require reactive power compensation to maintain voltage stability and power factor control. Devices such as static power compensators or static synchronous compensators are connected to the AC side to provide reactive power support. Yes, at the AC side, not at the DC side. In the DC there is no question of reactive power, but see, in HVDC system, at sending end, suppose if we are taking it as a DC, at the receiving end it is AC. So to support for this reactive power, we have to connect with the reactive power compensation devices such as statcoms, okay, synchronous I can say condensers or synchronous phase modifiers, etc. And that is one equipment. DC switchyard. See, here extra is DC switchyard. In HVAC only AC switchyard will be there. Here DC switchyard is extra, right? Control and protection. Yes, we have to protect and control HVDC system also. And communication equipment. Yes, through this HVDC we can transmission lines, we can send our communication signals also. So these are the equipments connected at the AC and DC side, or the DC side of HVDC system. Let's go for the next question. Yes, what is the next question? Method of neutral grounding. Yes, first of all, what is the purpose of neutral to be grounded? Generator or any equipment, three-phase equipment, neutral must be grounded. If not grounded, suppose if I take the case of a synchronous generator, there is no closed path for the flow of fault current. Whenever there is no closed path for the flow of fault current, then fault is not detected by this protection system equipment, mainly I can say relay. Therefore fault will remain, because of which there is some fault current which is flowing through capacitances of the transmission line, due to which the phase voltage will rise to line voltage. This concept is called as arcing ons or arcing grounds. Due to this, voltage will increase and insulation will damage. Therefore definitely neutral of the generator has to be grounded. All the types of groundings. Solid grounding is the first one. Means neutral of generator you are connected to ground without putting any impedance. Solid grounding. Yes. Next one is resistance grounding. See, neutral of a generator we are connected to the ground. That grounding is called as resistance ground. Resistance ground is preferred in synchronous generator to improve transient stability. Yes, third one is reactance ground. See, instead of connecting resistance or instead of not connecting it, means we are connecting neutral to ground, but that impedance is zero. That is called as solid grounding or effective grounding. I repeat, we are connecting the synchronous generator neutral to the ground, but not with any impedance or resistance or reactance, just a solid wire whose resistance is approximately very less or approximately zero. It's not possible to get any conductor to have exactly equal to zero resistance, but its resistance is very less. Then that is called as solid grounding or effective grounding. Second one is resistance grounding, which is preferred for synchronous generator to improve transient stability. Third one is reactance grounding. See, I am connecting one inductor from neutral to ground. Instead of inductor, I call it as reactance from neutral to ground. This is used mostly for synchronous motor. Why? Because most of the synchronous motors are overexcited. Overexcited synchronous motor will supply reactive power. Due to that, there may be a rise of voltage. To consume that reactive power, we are connecting this reactance grounding to the synchronous motor. Yes. Next one is high resistance grounding. It is one form of resistance grounding, right? Yeah. Next question. Yes. Give the specification of lightning phenomena. See, lightning will occur. Lightning always occurs in the form of current. See, most important phenomena or specifications are two. One is the amount of lightning current. The second one is the time up to which lightning will occur or happen. First one is, yes, lightning current. Lightning carries a substantial amount of electric current, typically ranging from 10,000 to 2 lakh amperes of current. Means 10 kiloamperes to 200 kiloamperes. Right, 20 kiloamperes or 200 kiloamperes, sorry, it is not 20k. See, 10k to 200k, right? The duration of lightning discharge is usually very short, typically in the range of tens to hundreds of microseconds, means 0.1 second, like that. 100 microseconds, 1 microsecond is 10 to the power of -3. 100 means 100 into 10 to the power of -3 is 0.1 second. That is the highest range of this lightning current to exist. Temperature and speed. Lightning is extremely hot with temperature reaching around 30,000 Kelvin, means 53,540 degrees Fahrenheit, which is hotter than the surface of the sun. Yes, you see, this is hotter than the surface of the sun. Yeah, the rapid expansion of air due to the intense heat creates a shock wave that we perceive as a thunder. The visible speed of the lightning can vary, but typically it appears to travel at speed of about the 1/3 of the light speed. See, the speed of this lightning wave is 1/3 of light speed. It's not equal to light speed. Yes. Frequency and distribution. Lightning occurs worldwide, but its frequency and distribution vary depending on the geographic location and weather patterns. Regions with high frequency of thunderstorms, such as tropical and subtropical areas, tend to experience more lightning activity. Yes, these are the important I can say these are the important parameters, or we can say that specifications of this lightning. One must remember these things. So all these questions are previously asked in Power Grid Corporation of India Limited interview for engineers, right? Yeah. Next, just go through it. What is this next question? Lightning arresters and its types. See, what is a lightning arrestor? Lightning arrestor is the one through which the lightning bypasses. Why? Because we have to protect our protection system, our transmission system, total our power system from lightnings. Why? Because lightning will damage harshly to our power system equipment. Therefore, we have to put this lightning arrestor. Suppose if you want to protect a substation totally from lightning, we are going with a mesh. We will put a complete mesh on that. That mesh is connected to ground. Whenever lightning occurs, that lightning will attack this mesh, and that mesh is connected to ground. Therefore, the total lightning will be grounded. If you want to protect our total transmission system from lightning, we are using a earth wire or ground wire or shield wire or a protection wire on the top of the transmission tower. That width of the wire is very small, but very less when compared to the power conductor. But it runs throughout the transmission system. It looks like this. See. Just it look like this. If this is our transmission tower, yeah, our earth wire or ground wire will run. See, this is earth wire. This is earth wire or ground wire. It runs throughout our power system transmission, right? Yeah. Rod or pole type arrestor, yes, distribution class arrestor, intermediate class arrestor, and station class arrestor, matlock surge arrestor. These are the types. Please go through it. These are the types. But this is very important. That is, if you want to protect our transmission system from, I can say, lightnings, just we have to go with the earth wire. So, but these are also very important. Yes, rod or pole type arrestor. Rod or pole type arrestor are the most common and widely used type of lightning arrestors. They consist of metal rod or a series of rods connected to earth or ground. When a surge occurs, the rod captures the surge and directs it to the ground, preventing it from flowing into the protected equipment. See, the main basic principle of this lightning arrestor is to provide low impedance path or short circuit path. See, I'll tell you, always current follows short path, right? So these rod type or pole type structures are offering less resistance. Therefore, total lightning will take that path instead of flowing through our equipment. Our equipment will not damage. Or very simply, if you want to understand the form of circuit, yes, I have, see, this is my equipment. And this is lightning arrestor. Both are connected to ground. Now, whenever lightning comes, whenever here lightning attacks. Now here lightning is coming. Lightning is having two paths. This is one path. But this ohms is some 1000 ohms, suppose say. It is approximately 0 ohms. Therefore, total lightning will take this path only. Lightning will not come into our equipment. Our equipment will be protected. This way, we are protecting our, I can say, power system equipment or our general equipments, right? And that, see, for distribution, intermediate class, these are the types. Please go through these things. Yes. station class arresters. See, station class arresters are heavy duty devices designed for high voltage systems typically used in substations. Yes, so these station class arresters are used in substations. So distribution class arresters are used in distribution system, right? So intermediate class arresters are for medium voltage systems, right? In distribution, see, distribution voltage is less when compared to transmission. Therefore, these distribution system arresters are for low voltage. Okay, yeah. Let's go for the next question. Let's go for the next question asked. Yeah, there are other types also, silicon carbide surge arrestor and all these things. These are the types. See, you can find many types, but one must know what is a lightning arrestor, what is the purpose of it, what are the basic types which are available in those, right? Yeah, what is smart grid? Yes, power grid is the company which is related to grid. Okay, so grid means connection of all the equipments to a single point in our language, right? All loads and sources to a single point. The grid is the one which is completely handling this total power distribution in entire India, right? So what is a smart grid? See, smart grid, see, I'll tell you one thing. Smart grid uses technology. Smart grid uses software programs for handling our power distribution and all. Means it is using technology. Let's go through it very clearly. A smart grid refers to an advanced electrical power system that incorporates modern technology, communication infrastructure, and control mechanisms to optimize the generation, transmission, distribution, and consumption of electricity. Yes, it is using technology for generation, transmission, distribution, and utilization. Yes. It is an evolution of traditional power grid aiming to improve the efficiency, reliability, and sustainability. Yes, what we can achieve with the smart grid is efficiency, reliability, sustainability. Yes, and overall grid performance. Here are some key characteristics and components of a smart grid. Advanced metering infrastructures. Yes, advanced metering infrastructures. Smart grids utilize advanced metering systems that provide two-way communication between the utility and consumers. These smart meters enable real-time monitoring of electricity usage and demand response programs. Okay, smart metering it is. Okay, advanced metering infrastructure. So both way, from source to load, from load to source, both sides it is monitoring. That is one of the very good characteristic of this I can say power smart grid. Generation of renewable energy sources. Sorry, integration of renewable energy sources. Yeah, so this integration of renewable energy sources is easy with smart grid than with the conventional grid. Okay, what is that? Smart grids facilitate the integration and management of renewable energy sources such as solar and wind power. They enable bidirectional power flow, allowing the electricity generated from renewable sources to fed back to into the grid while managing the variability and intermittency of these sources. Yes, it is bidirectional. Suppose, see, power is generated from wind station and it is feeding back to grid. But sometimes for some purposes that a wind station may require power, therefore power will flow from grid to that station. It's a bidirectional flow that is possible only with smart grid, right? Grid automation and control. Yes, demand response and energy management, grid resiliency and self-healing. See, this is very important. Whenever the situation of instability occurs, the smart grid is going to heal self. Means it is adjusting its, means it is rising its stability on its own. Means that way it is designed, smart grid. Read it. Smart grids are designed to be more resilient and capable of self-healing. They can detect faults, isolate affected areas, and reconfigure the grid to restore power unaffected parts of the system. Improves reliability, minimizes downtime, and enhances the grid's ability to withstand and recover from disruptions. Yes, so it can detect fault automatically. And it can renew the power. Means suppose if power is out there or power is down there, therefore it is going to restore that. Enhanced monitoring and analytics. So this is related to, see, monitoring and analytics. Smart grids utilize advanced monitoring and analytic tools to gather data on grid performance. See, this is one of the, see, I can say the sixth point is load flow related. So it monitors the entire year-wise data. Okay, so how much will be the next year, I can say a load demand, not year, next time how much the load demand will be, it will be high or low. All that analytics will be obtained and the performance will be optimized. Yeah. And yes, cyber security and communication. You know, these days cyber security is very important. See, smart grid is having that capacity also. Yeah. See, what is National Smart Grid Mission? So these things one must know before you go for Power Grid Corporation of India Limited. See, grid modernization. Yes, the mission aims to modernize the grid infrastructure by implementing advanced technologies such as smart meters, advanced communication systems, distribution automation, and grid management systems. This enables real-time monitoring, control, and optimization of power generation, transmission, and distribution. Modernization, yes. So India is becoming a technological country. Yeah, it is already a technological country. It is still advancing. So what is the main motto of our power grid is, I want to modernize it, right? Renewable energy integration. See, we have conventional sources like coal, thermal, I can say thermal. So instead of that coal based, we are moving more towards this renewable energy systems. Okay, demand response and energy efficient. See, this is also very important. Whenever there is demand, there should be more production, but efficiency is also important. Whenever there is less demand, the production has to be reduced, right? Yes. Let's go for the next point. Yeah. Grid resiliency and reliability. See, this is also very important. Reliability of power supply is very important. See, suppose if you take a city, there is lots of frequent power cut. Nobody want to live in that particular city. Yes, reliability of power supply is very important. Skill development and capacity building, policy and regulation support. Yeah, so these are the things which are required, or see. These are the things which are required for a national smart grid. Means national smart grid is working for this, right? Let's go for the next question. On traction, railway traction. See, we all know what railway traction is. Okay, what a railway traction is. See, we have these type of tractions: diesel traction, electric traction, dual mode traction. See, dual mode traction. These are the types of. We all know it is very simple question. Traction means how railway locomotives run, depending on these things, mainly diesel traction and electric traction. Okay, yes, that is very simple question to understand with. And these days a new thing came, that is hybrid traction. That is one of the important thing. Hybrid traction combines multiple power sources, typically diesel engines and energy storage systems such as batteries and capacitors. The hybrid system allows for efficient use of energy, regenerative braking, and reduced emissions. It is particularly useful in applications where trains operate in urban areas with frequent stops and starts. This hybrid system traction is urban. Suppose if you take metro trains, it requires frequent starts and stops. So this hybrid traction is very efficient. Okay, yeah. Let's go for the next question. Yes, yes. Let's go for the next question. Question is here. Yes, the question is, what are different household electric faults? In our houses, what different kinds of faults we will get? Yes. These are the different kinds of faults what we get at houses. Short circuit fault. Suppose if you are holding a wire and you are standing on the ground without wearing any footwear, which is, or if you are wearing footwear also, if it is not having resistance, then definitely a short circuit fault will occur. Ground fault. See, one of the wire is touching to the wall, or it is directly connected to ground. It's a ground fault. Overload. Yes, overload also can create fault. Suppose you might have been observed that whenever if you switch on iron box, rice cooker, washing machine, and fridge all at a time, yes, your MCB will trip. So this is one kind of fault that will occur. Arc fault. An arc fault occurs when an electric current flows through an unintended path due to damaged or deteriorating wiring, loose connections, or faulty switches. Arcing can produce high temperatures, sparks, and potential fire hazards. Arc faults are a common cause of electric fires at homes. This is very, very important. Suppose this is the wire, on this insulation you kept, but that insulation is not having withstanding capacity, then arc will occur. Arc will occur, due to which insulation will damage, sparks will come, and I can say fire will come. Fire will be created, due to which lots of faults these days are happening. So one must be very careful with this type of faults. Let's go to the next question. Yes, these are the various. These are also types of possible faults: electrical leakage and poor electrical connection. Okay, you know what is electric leakage? Yes, if current is flowing an unintended path. See, leakage means unwanted flow. It is called as electric leakage, right? Yeah. What is MCB, MCCB, RCB, or RCCB? Yes, very, very, for any interview, these are the very, very important questions. What are those? Yeah, what is MCB? Miniature circuit breaker. It is a small circuit breaker. Suppose if the overload takes place or high current flows, short circuit current flows, then immediately at our home, so that MCB is going to trip. Read about it. MCB is a commonly used device for circuit protection in residential and commercial electrical installations. It is designed to protect circuits and electrical equipments from overcurrents and short circuit. MCBs automatically trip and interrupt the flow of current when the current exceeds a certain predetermined value or when a short circuit occurs. They can be automatically reset after tripping. MCBs are available in different current ratings and commonly used in individual circuits within a distribution board. Yes, I think all of you got it. Very simple thing. See, whenever current is more than some predetermined value, MCB will trip. That's all. Next, what is MCCB? Modeled case circuit breaker. MCCB is more robust circuit protection device used in industrial and commercial applications. See, MCB is mainly for residential applications, but MCCB is more robust design. Yes, it is mainly used for industrial and commercial purposes. It provides higher current ratings. See, the difference between MCB and MCCB is the amount of current rating, that's all. Okay, greater basic breaking capacities than MCBs. MCCBs are designed to protect electrical circuits from overload, short circuits and download faults. They typically have adjustable trip settings allowing customization according to specific requirements of the electrical system. MCCBs are commonly used in larger electrical panels and distribution boards to protect main circuits or circuits with higher current demands. Mostly MCB and MCCB operation is same, but MCCB is designed to withstand more current and it is having some extra features like adjustment of the currents and all. What is RCB or RCCB? Residual current breaker or residual current circuit breaker is a device used for protection against electrical shocks caused by ground faults or leakage currents. It detects the imbalance between the current flowing in the live and neutral conductors. Yes. See, whenever there is a fault, then definitely imbalance of current will take place. This RCB or RCCB is going to recognize that imbalance in the fault and it is going to give trip signal to circuit breaker or it automatically trips. Yes, it automatically trips, cutting off the power supply and preventing electric shocks. This is mainly for the purpose of protection, right? RCB or RCCBs are commonly used in residential and commercial installations, especially in areas where there is a higher risk of electric shocks such as bathrooms and outdoor areas. Yes, this is the purpose of RCB or RCCB. Let's go for the next question. Yeah, the question is here, I think. Yes, what is the question? What is ELCB and HRC fuse? Yeah, see, ELCB and HRC fuse, most of the common terms we use. Let's go through. ELCB stands for earth leakage circuit breaker, while HRC fuse refers to high rupturing capacity fuse. HRC, high rupturing capacity fuse. Let's look at each of the devices and their functions. ELCB, earth leakage circuit breaker, is a safety device used to protect against electric shocks caused by earth leakage current and detects imbalance in yes, electric current flowing between live and neutral conductors. See, its purpose is also same as that of RCB or RCCB, mostly ELCB, right? Yeah, but it is mostly used in residential and commercial installations. HRC fuse, see, this is general fuse, but it is having high rupturing capacity. HRC fuse, it's a general fuse. What is the purpose of fuse? If the current is more than the predetermined value of current, then fuse will blow, that's all, right? Yeah, next question is, what are PWM inverters advantages, disadvantages and applications? Pulse width modulation inverters, PWM inverters. Let's go through it. So these inverters are electronic devices used to convert direct current DC power to alternating. That is a known point for us, to all of us. Yes, yeah. So what are the advantages of PWM inverters? Efficient power conversion. See, pulse width modulation, you know the concept of pulse width modulation. See, the main concept of pulse width modulation came into picture to improve the efficiency. This is efficiency, variable output voltage and frequency. The advantage here is by varying the width of the pulse, we can get variable voltage and variable magnetic frequency. Means, suppose I want frequency as 50 Hz, yes, I can get. If I want frequency as 45 Hz, I can get with the pulse width modulation. And yes, improved power quality. Yes, as it's a power alternator converter, we have lots of I can say lots of features in that. We will get that I can say like improved power quality. PWM inverters produce AC power with low distortion and high waveform quality. Means see, we always need pure sine wave. in inverter output. See, we have two types of inverters available, square wave and sine wave. If you install a square wave inverter, a fan will rotate like it will make some noise, but if you are installing pure sine wave inverter, fan will rotate smoothly. Okay, you might have been observed these things. Precise voltage regulation, we can go with we can get a good voltage regulation also with this PWM inverter. So these are the advantages. Let's see what are the disadvantages also. Yes, high switching frequency noise. See, we are using electronic switches which are operating at high switching frequency, therefore that high switching frequency will cause noise. Yes, second one is electromagnetic interference. Yes, electromagnetic interference will take place, complex design and control. So those are the general, I can say general disadvantages. What are the applications? Renewable energy systems, motor drives, and uninterruptible power supplies, UPS. Yeah, we all know these applications. In UPS, PWM inverters are used, UPS. Right, if it is renewable energy where the magnitude of I can say output voltage frequency are not constant, by using PWM inverters I am going to get my required magnitude of voltage and required frequency so that I can connect my device to the grid. Yes, so these are the applications. Motor drives. What is a drive? See, an electrical machine, yes, with a power electronic converter connected to work according to our requirement is a drive. Right, an electric motor is there. Suppose if you take induction motor connected with an power electronic equipment, that power electronic equipment is intended to give a required amount of voltage or frequency to that, so that I can get my required amount of mechanical output, speed or torque, whatever it is. So that is a drive, right? Yeah. What are the types of faults? Another is industrial automation. Yes, that all we know. What are the types of faults? Which fault is more severe? Yes, we have different types of faults. What are the different types of faults? I'll tell you here. See, the first one is open circuit faults, and short circuit faults. Again, this open circuit faults are of two types. One conductor open and two conductor open. Sir, if three conductors are open, it is not a faulty case. It is treated as no load condition. Our load and source got disconnected. One conductor open is a fault. Two conductor open is also a fault. Again, in this short circuit fault, we have grounded faults, symmetrical faults and unsymmetrical faults. What are the symmetrical faults? Triple L and triple LG are symmetrical faults, but both are same. Triple L and triple G fault, technically both are same, physically may not be same, but technically triple L and triple G faults are same. And we have unsymmetrical faults, those are LG, LL and LLG. These are unsymmetrical faults. Which one is more severe fault? See, on the terminals of generator, this LG fault is more severe. On the terminals of generator, LG fault is more severe. At any place other than on the terminals of generator, this triple L or triple LG fault is more severe. Right? So it is also possible to ask that what are the effects of short circuit faults, what are the effects of open circuit faults, what about power factor in short circuit faults, what about power factor in open circuit faults. These questions also are possible questions in Power Grid Corporation of India Limited interview. Right? What is SMPS? Switched mode power supply it is, we all know that. What is SMPS? Let's understand about it more in detail. Yes. What is SMPS? SMPS is a power supply that utilizes switching devices such as transistors to convert electric power from one form to another form efficiently. It is widely used in electronic devices and systems to convert high voltage AC power to DC power into regulated low voltage DC power. See, we have to go with the SMPS. Suppose if you want DC, right? From AC to DC, high voltage AC to DC. Right? See, here are some key aspects of SMPS. Operation: SMPS operates by rapidly switching the input power on and off at a high frequency, typically the range of tens of kilohertz to several megahertz. Yes, so the operation frequency is a range of some kilohertz to megahertz it is. So our power electronic devices, are, I can say electronic devices, can operate very fastly. And this switching action allows for efficient power conversion by minimizing energy dissipation and reducing the size and weight of the power supply. Components of an SMPS typically consist of several key components. Rectifier, yes, definitely rectifier should be there because it is converting from AC to DC. Switching transistors, those are the devices which we are using for the conversion of power, right? And transformer, if it is high voltage, definitely we have to decrease from high voltage to low voltage, so transformer we have to use. Filter, for the, see, if I want to get a smooth DC output, definitely I have to use filter. Never only a rectifier without filters can provide you with smooth power, right? Next, regulator maintains a constant. Yes, we all know what is a regulator. Suppose due to power supply, I can say fluctuations, I am getting any voltage between 100 to 200, but I want always 150 volts to maintain. The regulator, the duty of the regulator is to maintain that voltage as constant. Next, how power transformer protection is different from distribution transformer. Yes, this is one of the important thing. See, power transformer is used, I can say, at high power and high voltage systems, and it is connected in a place where transmission is involved. Distribution transformer is a small transformer, its rating, its capacity is small, and it is connected with a less number of devices. So see, protection of power transformer is very difficult when compared to distribution transformer. Let's discuss in detail. Voltage level of power transformer is very high when compared to distribution transformer. Fault current levels, whenever a fault occurs in power transformer, the fault current is very high when compared to distribution transformer, right? Yes. Next, production coordination. Power transformers are often part of larger network. Yes, therefore coordination is difficult. Distribution transformer is a part of very smaller network, therefore coordination is easy. Next, fault detection and protection time. See, due to the higher fault current levels and the need for selective protection coordination, power transformer require faster fault detection and protection operation. See, the devices what we are installing for the protection of power transformer must be very fast. Why? Because fault current is very high. If that much fault current is flowing for more amount of time, then definitely there is a possibility for the equipment to damage. Monitoring and diagnostics, those are very easy questions. See, these are the questions really previously asked in power grid interview, right? See, one must have good idea on our grid and basic converters like HVDC converters, rectification process, and about transmission losses. Only basic things, not in depth, but definitely all must have, one must know all these things, right? What is the, I can say, power generation capacity in India. So this type of questions will be asked in power grid interview. Thank you.